I repeat, we're just graphing today. And here we go. The first one we're going to graph is the one you just did. X cubed plus 2x minus 2. Yeah, I just started. So, we're going to do everything it says right here on the board. We're going to find the end behavior. We're going to find the x-intercepts. We're going to find the y-intercept. We'll talk about the symmetry. We might not do that every time, but we'll talk about it. And then we'll graph it as accurately as we can. E basically says we're just going to graph it. All right. So let's just go back to 41 and work on graphing this thing. All right. First things first. Let's find out the end behavior. We need to find all those things first. And you can write it all down as you're working if you'd like end behavior, write it down, and actually answer all the questions individually. But I prefer just to kind of answer it while I graph. What's going to be the end behavior of this particular function? Down, up. It is odd, positive. Odd exponent, positive leading coefficient. So it's going to go downward and end up going upward. Now you have to remember today we're just sketching. And we have enough things to make our sketch fairly accurate, but it won't be perfect. Okay, now let's see, part 2, I don't want to leave anything out. Part 2 said find the x-intercepts. We already did that in the DOM. They were -2, -1, and 1. Are they going to touch or cross at those places? Yes. They're going to cross because all of them happen an odd number of times. Let's see, what else did it say? It said, oops, wrong button. Find the y-intercept on any function. The y-intercept is just the number without an x. What number doesn't have an x here? -2. So -2 is the y-intercept. Now from here, just connect the dots. And again, it doesn't have to be perfect. And there you go. I'm sorry. That is a sketch of this function. Now, if you're a perfectionist, part E states, well, I'm sorry, I'm going to go back to that in just a second. Part E states you can find extra points using an XY chart if you want. Like, say, you're thinking, oh, I know 2, 1, 0, -2, -1, 0, 1. But to connect my behavior, if I just knew a few more, that's fine. At any time, I could have found point -3, -4, 0.2, 0.3. Just if you want to do that to get all the more precise. But the main thing I'm looking for are your intercepts, your end behavior. That's basically it. Intercepts and behavior and everything on the, well, yeah, I just did that. It's a big part. Now, it also talks about symmetry. You don't have to do this, but that's just another tool you can use to make it more accurate. We talked about, in the past, we talked about whether things were symmetrical around the y-axis or the origin. Does anybody remember what those kinds of functions were called? Something functions were symmetrical around the y-axis. Something functions were symmetrical around the origin. Does anybody remember what those were called? Even and odd functions, that's right. And essentially, you can know that just by looking. At polynomial functions, unlike absolute value and all that stuff, you can just look. Look at 41. Are all the exponents even or are all the exponents odd? No, that's a mix. So this one's not going to be symmetrical around either one of those axes. Whereas 43, the one we'll do in just a second, are all of these even or odd? Even. So I know it should be symmetrical around the y-axis. That's just something we remember from the past. So that's just another tip that you can use to know if you're doing this correctly. But before we do that, questions about 41, about how we came up with that. Okay, let's do 43. This is the only slide we're doing today, by the way. So I can work all of these if need be, or, you know, if we feel like we have a good grasp on it after 3 or 4, I'll cut you loose. All right. First things first. Part A said end behavior. What's my end behavior going to be? Up, 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 up. Now I also know it's going to be an even function, so I want this to look somewhat the same on either side of the y-axis. Again, it's just a sketch, so it doesn't have to be perfect. Okay, A part is done. We have our end behavior. Part B, we need to find the intercept. So let's go ahead and find the y-intercept. Where is it going to cross the y-axis? What number doesn't have an x? 0. There is none. So it's going to cross the y-axis right at 0. Now that's helpful in a way, but we'll wait till we get there. Yes. Now we need to find the roots, which we can do by factoring. What factors out of the top part? X squared. Now, I hope you remember from yesterday's multiplicity assignment, this implies what two roots? 2 zeros. What does this factor down to? You could just factor it if you're a good factorer. You could use quadratic formula. You could set it equal to 0. But those will give you -3 and +3. On which portion? Okay. So now we just plot those. 1, 2, 3. 1, 2, 3. And we're pretty much ready to go. There's 2x squared. Yeah, any x without a plus or minus is just a 0 root. Alright, so here we go. Coming down. Again, it doesn't look perfect, and I apologize, but we cross. What happens at 0? It touches. It goes right back down. Comes back up again. And, well, you get it. How do I know it doesn't touch here? Because I know it has to cross. Because it happens once, I know it has to cross. That's what we did yesterday. Again, you can plug in more points if you really want to be accurate. I'm only asking for a sketch, and this would be fine. But yeah, you could punch in -2 and -1, I mean 1 and 2 into your function. That'd be more than fine. And actually find what those exact y values are, but I'm not going to require you to do that. It crosses -3 and 3, and it just touches 0. Because it happens 2 times. Remember yesterday, the multiplicity, if it happens an even number of times, it touches and doesn't actually cross. If it happens an odd number of times, it crosses. And this whole thing would just be flipped over. It would look like this. It would still be 0, 0. But see, if there was a oh, you mean if there's a negative here? Therefore making one here? Yeah, then our end behavior would have been down, down. Yeah. And so the end behavior will kind of help you dictate whether it crosses going downward or upward. Because you know where you have to start by the end behavior. And if you know you have to cross, you know you're going to have to cross going that direction. Or if you started down here, you have to cross going upward. Yeah. Good questions. Other questions about this particular problem? Do a hard one? Oh, I like that. It means you don't think this one was hard. The ones that I would have to classify as hard are just the ones where it doesn't give it to you in nice and neat fashion. Okay, let's just jump straight into 63 then. I like it. Y'all are just tackling it head on. 63. Now, before you do need to FOIL this and get it into standard form. But before you do that, let's go ahead and take out the things we know. What are my roots going to be? Very good. -4 and 1. Now you may be thinking, why is it important? If we can see our roots, why is it important to FOIL everything out? Because you don't know the y-intercept without doing that. Although there are ways you can find it, and I'll show you that in a second. And you don't know what the end behavior is. Again, there's ways to do that, and I'll show you how to predict that in a second. And you don't know if it's going to be even or odd symmetrical. Now, let me ask you this question. If we were to just FOIL the last two pieces, what would the last term be in that FOIL? It'd be -4. Right, the last two numbers. That same principle, before we go any further, are there questions about how she got -4 if you were to FOIL these two, you do the first, x squared minus x plus 4x minus 4. The last term will always just be the product of the last two pieces. Well, you would have to multiply everything. It doesn't really matter what order you did it. And we'll do that in just a second. It's ugly, but we'll do it. But that same principle holds true. You're going to end up multiplying all four of these pieces together, but you can figure out what that last term is supposed to be the same way. What are all four of my last terms? -1, +4, and 2 -2's, right? So if you were to multiply all those together, -2 times -2 is +4, times +4 is 16, times -1 is -16, and you can predict, no, we're still going to multiply it out and let you see it. Well, let's go ahead and just predict that our y-intercept, that last term, is going to be -16. Also, does anybody have a prediction for what our leading term is going to be? You're right. Our leading term is going to be x to the 4th. Why? Because there's 4 x's. That dictates the 4th, and they're all positive. So let's actually FOIL it out now and see if we can't come to those conclusions. All right. I'll do the first two pieces first. X minus 2 squared is x squared minus 4x plus 4 when you FOIL this out. The last two, when you FOIL, it'll be plus 4x minus 1x, so plus 3x. I'll give you a second to write that down. Now we have some real fun FOILing to do. We'll have 9 terms when we're done. Here we go. First, well, here's the way I like to do a 3 on 3. I just take this one, multiply by all 3, and then the next one by all 3, then the third one by all 3. X squared times x squared, x to the 4th. X squared times 3x, 3x cubed. X squared times -4, -4x squared. Then we go to the second one. -4x times x squared, -4x cubed. -4x times 3x, right. -4x times -4, plus 16x. 4 times x squared, 4 times 3x, and then 4 times -4. Like terms time, we only have 1x to the 4th, and every time we do something, I'm going to cross it off so that we remember. We've got 3 minus 4, so 3 minus 4 is -1x cubed. Let me cross those off. Let's find our x squared. -4 minus 12 is -16. -16 plus 4 is -12. Cross all those off. 16x plus 12x is plus 28x. And then the 16 is just hanging around there at the end. So sure enough, we predicted y-intercept is -16, and x to the 4th was our leading term. So that'll tell us our end behavior, positive, positive, and our y-intercept, and that's all you really need to find. And you can now see it's neither even nor odd. Yeah. I FOILed these two together. X squared, it was x squared plus 4x minus 1x minus 4, which became plus 3x. When you, I'm sorry. It would be -1x plus 4x when you FOIL. That's the way I prefer to do these. You could have FOILed these, then multiplied all those by this one, then multiplied all those by this one. But I prefer to pair them up. Do 2. That's essentially what we did. 4 times x, 4 times -1, x times x, and x times -1. All 4 of those terms. And then we just combined them. X squared plus 3x minus 4. Yeah. It sounds like we just did it in a different order, but you should have got the same thing. So we're just ready for the graphing. Questions about any of the algebra we've done so far? Nope. All right. No, that's not nearly enough space. All right. Actually, it's funny that Devin said let's do a hard one because in some ways these are the easier ones because they're pre-factored for you so you can pull your roots straight out. So what was the end behavior? Up, up. Y-intercept was negative 16. That's fine. Sure. Yeah. In these sketches, I'm not going to be that critical. All right. It's going to cross at negative 4. It's going to cross at 1, and it's going to touch at 2. So here we go. You have to cross there. It's going to come way down here and go through that intercept. It's going to cross at 1 and touch at 2. May look funky, but again, just a sketch. It crossed at negative 4. Only happened once. Questions about that one? Any questions about that one? All right. Let's see if we're forgetting anything. I don't think so. Take a look at this page and feel free to ask about any others that you'd like. Sure. How about 61? I forgot to take the evens out of this page for part of it. No way. 61. All right. What are my zeros? If you have one that's prefactored, just go ahead and find your zeros. What are my zeros going to be? That's not all. I should have 6 total. I see what you're thinking about. You're right. Hold on a second. What's going to make this equal to 0? 0. It's only going to be negative 2 if it was like x plus 2. So the coefficient in the front doesn't really change the fact that these are still going to give you zeros. Yeah, 0, 0, 0, 1, 1, and negative 5. It won't affect the zeros, no. And it won't affect your intercepts. That will only affect your end behavior. Yes, yes. Whatever the degree is. Now, technically on this one, we can't pull out the degree yet, but we know that there's 3 x's here, 2 here, and 1 here. So that means there's going to be a total of 6 in the end, so that should be your root. Now, in the next section or two, we are going to get to the point where you have to find your own zeros a little bit more complicatedly than this, and some of them may be imaginary, which means that it won't actually cross 6 times or touch it however many times, but nonetheless, there should be 6 accounted for, even if they're all imaginary. Negative. Do you know the y-intercept? Let me stop you right there and just say, yes, you can. Again, that's the point I hope everybody in here gets to, where you can look at something and you get to the point where you're comfortable knowing what you're looking for, to where you can know where to look in the problem, and yes, you can start cutting more and more corners, and that's fine. But since everybody doesn't get there at that same speed, I'm going to show everything every time, but you don't have to. The y-intercept? Good question. Let me ask you something about it. When I FOIL this together, you're right, my last term would be negative 5, right? But then when I multiply by this, am I going to have any entry that's going to have any x value less than 2? You won't, and I'll show you. If you ever have an x out here in the front, you should find that your y-intercept will always just be 0. And actually, this kind of implies that anyway. This says you have an x-intercept at 0. Well, how is it talking? That's on the y-axis, right? So that kind of anytime you have a 0 x-intercept, that is an indicator that your y-intercept will also be 0. That's true. No. You don't have to show me any algebra today. All I want to see at the end of the day is all the graphs. I know some of you could just punch those in the calculator and look at them. And if you choose to do that, that's fine, but you'll probably be sinking yourself on the test. So you'll still need to do this if, as much as you need to. But I only want to see the graphs on your paper. So anywho, here we go. Oh, right. We're going to do the algebra first. All right. So, FOILing, I'm just going to do the middle portion first. That'll be x squared minus 2x plus 1. Let's see, then I'm going to do the last pieces. That'll be x cubed minus 2x squared plus x minus plus 5x squared minus 10x plus 5. Combine your like terms. Then when you distribute, I think this is what, going back to what you were asking me, Adam, when you distribute that, you're going to get 2x to the 6th plus 6x to the 5th minus 9x to the 4th minus 10x cubed. So you're not going to, you can see here that you're not going to. Again, I'm not going to require you to show your algebra, but yes, you're right. In fact, this one that will be a plus as well. I forgot to do signs on both the middle ones. There we go. The whole even or odd thing about whether or not to know whether it's even or odd by looking at the function, I don't know what shortcuts to tell you. I know there are some, but I'm having trouble thinking of a way to tell you a shortcut to look for that, short of multiply everything out and now just see if it's even or odd. I can't think of a shortcut to tell you for that. So remember, there was one thing I said we were just going to talk about it. If all the exponents are even or odd, you can assume symmetry of whether it's either over the y-axis or the origin. It's a good thing to be able to know, but no, everything else should fall in place. Yes, it is. Thank you very much. Don't hurry on your assignments, or you'll make these kinds of mistakes. You got it. And let's do that now. What's my end behavior of the original? Let me go back to that. Oh, I guess it's right here, isn't it? It was down, down. I don't want to scroll back up. What were our roots? And so you can see right here, it's not going to be symmetrical. You should be able to look at your roots and conclude something. I don't know if it's always conclusive. What were we talking about? Oh yeah. Did it touch at any of those? Which one? No, it should have crossed at 0 because it happened an odd number of times. Which one happened twice? 1. 1 is the only one where it's just going to bounce. So we're going to come up, cross. Well, darn it. Well, it should have gone through that. And right there. Ish. Now, what if, this is just a discussion point real quick. Just a discussion point. This thing was x to the 6th, right? So what's the most number of times it could have crossed the axis? 6. And let's say it had crossed at 6 different spots. 1, 2, 3, 4, 5, 6. And it looked something like this. Boom, 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 boom. Okay? So that's the most it can have. One thing, I believe the wording on part E in your book says, if necessary, find a few additional points and graph the function. Use the maximum number of turning points to check whether it's drawn correctly. That's referring to the degree is the maximum number of times it can cross the axis. Now, if we actually count the turning points, which basically means the max and the min, that's 1, 2, 3, 4, 5. The number of possible routes minus 1 is the maximum number of turning points. If that makes any sense. Just to go back and read and cross the axis, the function has to turn around and head back towards the axis. So when it reads the maximum number of turning points, that simply means it could have turned degree minus 1 time. They won't all. Like you take just regular x to the 6th, that's just a parabola that only has 1 turning point. So I'm not going to require you to throw ripples in your function every time it doesn't cross that many times. But just know that's what it was referring to. So if you're thinking, oh, this was x to the 6th, why didn't it have more ripples in it? It was saying, if necessary for self-validation, you can plug in more points to see, but not really necessary. Because I don't really care about the ripples. Questions about this problem that we just worked on? Is there a specific one on this screen that we haven't worked on that maybe somebody has a question about?
I don't want to take the word about, but that's what number 55.
Mm-hmm.
This is going to be my name. So why would it be 4?
Yes, it would.
Know that.
Oh, well, no, actually it wouldn't. You're close, but you're forgetting there's 2 negative 1s, and this isn't fully factored. See, this is kind of a little curveball. It's not one of these where it has a square. The square is to the side. So this would actually be x plus 2x minus 2. So you'd have to go -1, -1, plus 2 minus 2. Then multiply those together. Actually, that might end up being 4 anyway. But anyway. Once you do that, yeah, you can just take all the last ones over. And don't forget to multiply by this as well. The number in front. So that's going to multiply by that. So it would be 1, 1, positive 1, 2, negative 2, negative 4, right? Times negative 3 would be positive 12. Your line. That's a good question. I hope everybody heard that. He said, and he used this one, he said, can you just immediately, like we did on one in the past, I don't remember which one it was, I think it was this one, can you immediately just multiply those numbers and know which y-intercept is? Yes, assuming it's fully factored, and don't forget your leading coefficient, because that's going to end up multiplying it as well. So like 56, that would be 2 negative 4s, so 16. Then this is going to be what? Plus 5 minus 5? So 4 times 4 times 5 times negative 5, that's 400 times negative 2, and that would be your y-intercept. Going back to what Hannah asked earlier, great time to use a break in your graph, unless you want to go up to 600 or whatever that would be. Good question. Very good question. Any other questions from this page? All right. This is all you have to do. There it is. That's what I need from you. All I need are the 10 graphs. That's 10 problems. We're all graphing. I just need 10 graphs.